In this video, we will discuss the high-level aspects of designing a class in Java. This video will serve as the first step towards learning how to build a full class in Java. In case you haven't noticed, but we have already dealt with classes in three separate contexts. As a blueprint for objects, which is the building block of the object-oriented programming paradigm. Think of the string class in the lang package. We used it as a blueprint to build different string objects. We also dealt with the class as a container of the main method, which makes this class work as an application. We have done that in every single demo in previous videos. We wrote all of our codes inside the main method, inside the class. We also dealt with classes as utility classes. Classes that contains useful constants and methods we can utilize without the need to build an object from it. Think about the math class in the lang package. We used its pi constant, pow, and square root methods without creating a math object. Notice that for all of these classes with different usages, they all follow the same structure. You can define attributes and they have methods. In this and subsequent videos, we will learn how to write the blueprint classes from scratch. We will discuss a systematic approach that will make the process simple. With that said, however, it's unavoidable to write application code to utilize the classes that we will define. So we will be doing that also. Alright, so let's talk more about the class as a blueprint for objects. We know that an object is described as a set of attributes and methods. As a programmer who is defining the class that describes the object, you need to think of the attributes and the methods. In general, you aim to make the class as focused as possible. A class should be highly specialized to represent a single concept. The class should also be self-contained, with all of the attributes and methods that adequately describe the object defined within the class. This process is called encapsulation because you encapsulate the attributes and method into a single concise entity. Encapsulation is one of the pillars on which the OOP paradigm is built. The three other concepts are the abstraction, inheritance, and polymorphism. We will start by discussing the encapsulation and learn how to build efficient classes. Once we create the self-contained focused class, we can create any number of objects from it. Think of the class that represents a blueprint of a specific home design. We can use the same blueprint to build multiple home objects. And that's why we say that each object, or a home in this case, is an instance, realization, or an instantiation of the class. All houses will share the plan defined by the blueprint. They have the same set of attributes and methods. Yet, each object is an independent entity that represents a unique object. The uniqueness comes from the difference in the attribute values and the fact that each object owns its own set of methods. For example, all homes will have an address field, but the number in the address field will be different. Let's take an example of a class that we have already dealt with, the string class. String class is used to create strings. Assume that I will initialize three different strings to represent a person, a pet, and a color. All strings share the same design defined in the string class, attributes and methods. Each string has a value and a set of methods such as the length, char_at, and so on. They are, however, unique. Each instance of the string class contains a different string stored in it. Also, each string has its own copy of the length, char_at methods. For example, if I type person.length, the length method owned by the object referenced by the reference variable, person, will be called and result in 5 because the string Jenny has 5 characters. On the other hand, if I run color.char_add2, it will run the char_add method owned by the string object referenced by the color reference variable. This will result in the character D to be returned because this is the character in position 2 of the string red, and so on. Excellent. So now we know the high-level structure of the class. It has attributes and methods. We also know what the object that will be instantiated from the class will look like. So how do we define a class in Java? You need to tell Java that you are going to build a class to define a class in Java. The header of the class contains three parts. The last part is the class name, which is the identifier of the class. If you remember, we said that this would be a noun or multiple nouns, with each noun being capitalized, leading to the camel case format. The class in this line is the keyword that tells Java that what you are declaring is a class. So what about the access modifier? An access modifier is a keyword that indicates how a field, a method, or a class will be accessed. Is it available for all other classes? Then set the access modifier to be public. Or is it private and shouldn't be accessed from outside the class? Then set it to be private. A protected access modifier is an intermediate level of access, and it's accessible by other classes that belong to the same package, but inaccessible from outside the package. So putting it all together, a class for interest calculator can be declared as public class interest calc. Notice that both public and class are lowercase, and the name of the class follows the camel case format. In general, classes are made to be used, so they are mostly public, unless they should be private or protected. If you define multiple classes in the same .java file, which is possible, you will need to set only one of them to be public, and this class must have the same name as the .java file name. An OOP program is nothing but a bunch of objects instantiated from different classes and set to interact with each other. So defining a blueprint class is not sufficient. You need to build a program that will create objects from the class. In the following videos, we will learn how to create the blueprint class and how to create the application to use it.